This is Advent of Code 2020, day 25. The puzzle is called Combo Breaker. We're at our destination. We've reached the registration desk, but we find out that there is some issues that they're having. They're calling technical support, but in the meantime, we're able to take our room key 25 flights up to our floor, and after huffing and puffing all the way up those stairs because the elevators are busted, we find out that the card that we were given is not working with the door that we're supposed to go in. So we talk to tech support and find out that maybe if we're smart, we can reverse engineer the cryptographic handshake in this card, and through that we'll be able to send an unlock or open command to the door. So for the first part here, we're going to take the public key for the card, the public key for the door, and use those to deduce what the loop sizes are that both the card and the door each independently use in order to do signing of the messages that they send. Yeah, there's a lot of details here, but I guess the thing that I want to highlight is these two steps here are what we do each time we loop. So in order to find the loop size, we'll take our starting value of 1 and the subject number, which we've been told is 7, and we're going to loop as many times as it takes until we reach the public key for each of these, for both the door and the card. And once we've figured out each of their respective public keys through this method, or rather, once we've knowing their public keys, we'll be able to deduce the loop size for both the door and the card. And then from there, we can take those loop values and we can have them encrypt each other's public keys, which we'll treat as the subject number at that point. And we should get the same value for each of them, and it's that encryption key, that the resulting encryption key is what our answer to the puzzle will be. So yeah, I think we can just dive right in with knowing these two rules and see where we can get. So I'm going to come over here and pop open a part1.ruby file. And I'm just going to paste those rules there. I think for starters, I'm going to ignore the given puzzle input and instead see if I can produce these two values. So the card's public key is this. Say card public key is that number, and then the door's public key is this number. And we want to figure out what are the loop sizes for card and door. So to do that, we're going to have to follow this looping equation here. So I'm actually going to paste that in down here, and we'll say while value is not equal to card public key, we'll say value gets multiplied by itself. It itself is multiplied by the subject number, which will start out as 7. And then, yeah, maybe we can document these two pieces. So subject number is 7, and then the starting value is 1. Okay, so that's step 1. And then step 2 is to then set the value to be value mod 2020 1227. Great, so we'll just keep looping until we end up with a value that's equal to the card public key. And I guess the other thing we need to do here is card loop size is 0. And so each time we're in here, say card loop size plus equals 1. What's it saying? Oh, it wants to do the self, I see. Multiply equal, that's fine. And yeah, so I'm kind of curious if we run this, if we can get the correct card loop size. It runs, we get 8, and I think, yeah, cards public key, 8. That's great. So then if we are to do the same thing for value equals 1, door loop size equals 0, we follow the same formula. Changing that to be door, changing this to be door, and then everything else should run the same, and then we'll want a similar puts at the end. Oops. Door loop size, and over here as well, door loop size. And if we run that, great, we get 8 and 11. And 11 was what we wanted here. Or there we go. So that's the loop size for those. So then knowing the loop size of each, we can then run this same sort of series of steps with those specific loop sizes in order to derive an encryption key. And then instead of using 7 as the subject number, we'll use their respective public keys as the subject numbers. So let's try that. Run an encryption, and we'll say this is the subject number and the loop size. Just thinking I'll break out a dedicated method here to do essentially what we were doing in the logic here. So instead of counting the size anymore, we'll just actually do these specific steps. So we'll say loop size times do for each of these steps. I'll say value starts as 1. We get passed in the subject number. This value stays the same. Sure, we could do that. And then, yeah, I think we just want to return the value then at the end. And so we would like to puts out the door encrypted value. It's going to be run encryption on the card public key and the door loop size. And then we'll do a similar thing for the card, where we run it against the door's public key using the card's loop size. And oh, whoops, I didn't close that. Gotta close that. And now I think we've got some valid syntax that we can run. Let's see where this gets us. Yep, we produce these same matching values, and that is this value here, which would be our answer if these were our public keys, but we now want to work with these are going to be the two values we're working with. I'm going to copy them. I'm now wondering if it probably doesn't matter which is which, like which is the card public key and which is the door public key, because at the end they're both going to be used to just get to some shared value. So if I paste these in, just replace one, replace the other, and then I guess we can just run the thing and see where we get. Yeah, we produced some shared values here. Must have looped a bunch of times because it definitely hung there for a second. Let's copy that over and see if we've got an answer. And all right, we got our first gold star for the day. That was part 1. In the next video, we'll look at part 2 and see if we can finish out Advent of Code. Thanks for watching.